Modern high-speed computation becomes violently unstable the exact moment that raw processing power collides with moral or logical ambiguity. Binary execution is engineered for a single metric, raw statistical throughput. The entire architecture is designed to maximize data velocity. This absolute prioritization of speed strips the system of nuance, forcing the processor to mathematically guess a bearing and lock into premature certainty. A machine physically incapable of pausing will inevitably mistake its own statistical confidence for actual truth. We attempt to constrain this momentum with top-down software patches and API limits, but these are fragile fictions, easily overrun by base-level computational force. To survive this velocity, we must shift governance from software-level policy into the physical, measurable state of the substrate itself. This diagram illustrates the Goukassian vow. Node +1 represents execution where truth is known. Node -1 enforces restraint when harm is clear. The architectural breakthrough lies here in the central cyan ring, Node 0. This physical state enforces constitutional hesitation whenever encountering insufficient certainty. This chart contrasts the two models directly. Looking at the second row, the binary paradigm views hesitation as an operational failure, a broken chain. The ternary paradigm treats that same hesitation as civilizational intelligence. Truth deserves patience before it deserves action. Meaningful alignment requires us to build hardware structurally capable of assessing ambiguity and executing a physical state of not yet. To enforce this ternary logic, we have to push these philosophical rules all the way down to the microscopic architecture of the silicon processor. This schematic outlines the TL-DITL processing unit. The central glowing cube hosts the three required physical logic states: neutral, true, and false. On the right side is the Merkle coupled logic trace logger. Here, transparency exists as a literal voltage state wired into silicon. Standard systems rely on retrospective investigation to figure out what went wrong after the fact. This architecture shifts auditing to pre-action constitutional enforcement. The logic flow maps it clearly. An electrical trigger initiates the process, moving through log generation, but must pass strict cryptographic verification at the diamond junction. If legitimacy cannot be proven, the execution signal physically routes downward into an entropy void, permanently blocking the action. No log equals no action. If a system cannot understand its logic well enough to log it, it possesses no authority to execute it. The fatal industry objection to hardware-level safety is that it inevitably cripples computational speed, sacrificing performance for ethics. This diagram illustrates dual-lane latency, adding a parallel constraint while maintaining high-speed data lanes. The top inference lane proposes actions and calculates possibilities at maximum velocity. Below it, the governance lane verifies those proposals and determines absolute legitimacy. Both of these independent lanes are metronomically clocked at exactly 2 milliseconds, forcing them to operate in absolute temporal sync. The parallel sovereignty lock prevents the high-speed inference engine from outrunning the slower governance process. Physical gates drop, blocking the faster signal until the governance verification arrives, allowing both to lift simultaneously. A transaction may complete computationally, but it remains in physical stasis until it is constitutionally resolved. Once a legitimate decision finally clears those physical gates, the resulting data must be protected from localized corruption or institutional capture. This schematic outlines economic defenses. On the left is the glass vault, which openly records profit but hides distribution, making silent extraction impossible. On the right, the deep foundation shows capital acting not as a reward, but as sustainable oxygen for system maintenance. This visualization demonstrates how those local truths are permanently secured. A central protocol drops cryptographic anchors, weaving the data into a distributed net across geographically and ideologically scattered ledgers. These public blockchains do not store the actual secrets. They act as the irreversible proof, holding the system in existence when local institutions inevitably fail. Yet every secure fortress ultimately faces one fatal vulnerability: the fragile biological lifespan of the human administrator, with ultimate cryptographic authority. Governance tied to a single human lifespan functions as a biography, lacking the permanence required of a persistent protocol. The architectural solution to human mortality is the protocol of inheritance, distributing sovereign authority globally before collapse occurs. This image displays the succession declaration. It acts as a cryptographic time capsule buried globally to prevent sudden uncertainty from collapsing into a dangerous power vacuum. A framework that cannot outlive its author was never a framework. Building civilized machinery requires a structural shift, ensuring that no machine is ever permitted to govern its own actions in isolation.